I'm Chamini Singha, an undergraduate of Sabra University of Sri Lanka. So it's my pleasure to have you all in this session today. So first and foremost, I would like to welcome you all to the Bootcamp for NASA Space Apps 2022, powered by SEDS Sabra in collaboration with SEDS Sri Lanka. If you are looking for a helping hand, there's one at the end of your arm. So with that, we'll go ahead. So now I'm going to give you a brief introduction of today's session. As space enthusiast, I hope that you already know about the annual webinar series by SEDS Sabra. So just as that, this bootcamp for NASA Space Apps is also basically designed for dynamic individuals like you who are willing to represent Sri Lanka in international platforms. So if you are such a just stay connected with us because today's session on spatial technology will surely be a very fruitful, effective, and also an informative session. So, do you know what geospatial technology is? Yes, it is relatively one of the growing applications in the space of emerging technologies. Geospatial technology plays a vital role in our daily activities and is embedded in most of the systems and applications we use today. So we'll learn more about this topic. So today, Ms. Panchali Umeshika Fonseca, a research scientist at Arthur C. Clarke Institute for Modern Technologies, is going to share her valuable knowledge with you all. Before moving to the session, I would like to inform you that at the end of the session, you will get time to get clarified all your issues regarding geospatial technology. So I'm not going to speak further and I will move to the valuable session which you all have looked forward to. So I would like to hand over the session to today's resource person, Ms. Panchali Fonseca. Madam, it's over to you.
Thank you, Chamini. Very good afternoon, all of you, and thank you, SEDS Sabra, for inviting me to have this lecture. And it's really my great pleasure to be here as an alumni of Sabra. So as Chamini said, this webinar series is conducted parallel to the Space App Challenge 2020. Let me share my screen first. So actually, this is the real problem which we have encountered when working with students, because most of the time, most of the students can collect geospatial data very accurately. They use tools, softwares, and sometimes they develop their own programming codes to process this data. But the problem arises when they are going to apply those data into the real world problem, because most of the students don't have a real scientific background behind each and every problem. So actually, if we are going to answer a problem which is happening on real, we need to understand what is the interaction behind that. So that is why we need to study the Earth system as a science. So then we can apply the geospatial technology very well. So we all know that Earth is a complex system. So it's composed of multiple physical and biological processes. So people have been studying about the Earth for a long time. For example, geologists study the formation of rocks, and meteorologists are interested in the atmosphere and other things. So a deep understanding of the physical environment Earth, which has been built over past few years. But it is very recently when the satellite have started and allowed us to see the Earth as a whole. So to parallel to that, when the human activity makes an essential to model, and we're going to talk about the Earth system science in deeply and about the geospatial technologies too. I will give you a brief introduction, what is actually happening and what is existing, so you can go further if you need further knowledge. So let me start from the beginning. Okay. So this is population clock. This is a last year clock, and the population right now it's increasing than this. It could be 9 billion, 7 billion people. So that means human population is increasing. So very fast. And how far, what will happen to the bee? Yes, higher temperature, more heat waves, rain and snow pattern changes, and more droughts and wildfires. And we can hear about the snow melting and damage of coral, warmer ocean. So all these things happen not because of the number of people is increasing, but the scale and the nature of the consumption is increasing. So let me revise the question now. On the other hand, what will happen to the human population if the Earth system science change? So the answers will be storms and flooding, heat, air pollution, low food supply, mortality, malnutrition. So you can, as a people, we have to face a lot of difficulties. So to understand the phenomena, we need to study the Earth system well. So problems related to the Earth is complex, and it is easier to understand the problem by breaking down into smaller components. That's how the world system came. Okay, so the system is a smaller component, and by making a system together, we can understand about the larger complex system. So actually, what is a system? We usually use a concept of system to study the complex problem, and there are so many definitions. So to explain easily, I will say that it is ability defined by ability to exchange matter and energy. So according to that, there are three types of systems: open system, closed system, and isolated. Isolated system is where the matter and energy is not exchanging. Actually, in reality, there's no isolated system. Closed system mean only energy is exchanging, but not the matter. So for example, you can have the pressure cooker. An open system is where both the energy and matter is exchanging. So for example, if you have a pot on the stove with open lid, so it's a very good example for the open system. Okay, so among these three types, my question is, Earth is a closed or open system? So I would like if you can answer me by using the chat box. So no one is answering. Is the Earth is closed system or open system? My question is the Earth is a closed system or a open system? So the answer is, it is considered as closed, nearly closed, because energy can enter and leave the system. For example, the Earth has temperature, so it radiates energy to the space. And on the other hand, Earth intercepts the energy radiated by the sun. And the second point is, vast majority of matter cannot enter or leave. Yes, vast majority of matter cannot enter or leave, but a tiny amount of matter can exchange. For example, comets, meteorites are coming in, and hydrogen, helium are going out. So therefore, we consider Earth as a closed system, and there are some implications. The thing is, resources are finite, can't throw things away, and changes in one part of closed system will eventually affect the other parts. So, as I told you that Earth is very complex and it has complex interactions. So, studying about these complex relationships, we called as a Earth system science. So what scientists did was they studied each and every smaller systems of the Earth to take the picture of planet Earth as a whole. So for example, it's similar to the human body system. All human body systems work together to maintain a body that functions well. So in terms of Earth system science, each of these systems allow Earth to keep itself in balance. So a change in one system will affect the other system. So when we study about what will be happen and what will be happen to next and what are the consequences, so how we manage the resources, likewise. For those things, we need where the thing is happening and what is the phenomena happen there and what is the region which affect that phenomena and what is the relationship between human activities. So likewise. So if we know these answers to these questions, we can easily model. And for model, we need geospatial data. So to understand the reality, we need modeling. And for modeling, we need very accurate geospatial data. So in simply, geospatial means a location-specific data. So when it is come to the geospatial means, it's really anything related to the location. So if you talking about geospatial data, so how this translate to the technology? So geospatial technology means a collecting and analyzing geospatial data. So actually the geospatial technology is a collective term for various modern tools and systems to help us to map the Earth's surface. So the term geospatial technology is actually broad and it covers a host of different a brief idea. So let me play a video first. It's really applicable to the GIS. So using GIS means you're not making maps. You're trying to gather information. You're trying your best to gather information about something and you're going to solve the problem. So that's why GIS is very powerful. So actually, GIS is a collection of computer hardware and geographical data. Geographical information systems we use it for storage, retrieval, and analysis of geographically referenced information. GIS is considered as actually the primary tool for spatial analysis. Anything which has a spatial context can be studied using GIS. It is a tool, it is a system, and it is a science. So there are so many disciplines integrated with GIS: cartography, computer-aided design, survey, geodesy, remote sensing, and therefore. But these disciplines answer the question, what and where it is. But we need to know, when we are going to talk about the Earth system science, we need to know how the thing is happening. So that's how the GIS science is coming to the field. So GIS science conceptualize how to store spatial information and how to collect it and analyze it. So then it can be integrated with many other geographical disciplines like computer science, geodesy, mathematics, environmental science, and etc. So geographical information system always relies on the development of GIS science in each and development. So in other words, we can consider it is as a building block Okay, so I stop from here, and what we can do with GIS. So we can find a feature, find a pattern, find in map quantity, find in anything nearby. So as I said, a heart of GIS is geographical data. And we have two components, spatial component and non-spatial component. If we have a better collection of both spatial and non-spatial data, we can have a very good application. For example, this is a RAT portal. So this is the overview of the RAT information portal, and we can zoom in until we need our location. And when we click the location, so we can see some attribute data, the dates and who visited the location and what is the initial inspection likewise. So here you can see that if you have very good map layers, then you can use it easily and assemble to make map, not only static, but also the dynamic maps. So if you're going to collect data and handle it with GIS, then you need to have a very good database. So a data is a single unit of information, because for the information we call the collection of data. So, but we need database because if we store our data within a database, we can restore data and we can manipulate data very systematically. And we can use it for a spatial analysis using some algorithms. So database is very critical component in GIS. So when you add a location-based information to the database, it's a part, particularly spatial index optimization, or we call database scheme design information. So if you need to learn about the geographical database, there are so many different kinds of database system: personal database, geodatabase, enterprise database. So you can read on those database more if you need further information. So this is one of the examples when we handling data. We need to really carefully handle those, because if we didn't carefully handle, the situations might be very crucial. This is happened in California. So this is a pipeline exploding. They use GIS to, and they use database to store their data. And so that's another. This is happened to the flight in USA. 40 people died, and the reasons is not actually the accident or anything else. If you see the reasons, you might. The first picture, the reason is omission or data entry error made when they are making the central management system. For the second, the reason is they use outdated airport map, and he took off on a wrong runway and crashed. So the airport was updated, but the map was not updated. So you can see that if you did not carefully handle the data, then the consequences will be very bad. So as I show in my previous slides, the plane was crashed because the data is not up to date. So in Sri Lanka, we have very old data set in each and every local departments, and updating data is very difficult because they are using field observation most of the time. So the Earth observation come into the field when the field observation is difficult and takes time. So we call Earth observation, or sometimes we call it remote sensing. Remote sensing is the science of obtaining physical properties of area without being there. And so it uses various of sensors to capture the image. For example, airplanes, satellites, and UAVs. So, and they have specialized platform which carry different kind of sensors. And each and every sensor have its advantages and disadvantages. So if you want to capture an image, you have to consider facts like what are the flight restrictions, what are the image resolution, and the coverage. For example, satellites capture data on a global scale, but drone, they are better fit for flying in a small areas. And for the airplanes or helicopter, it takes the middle range images. So there are three orbits where satellites are orbiting, and the three types are geostationary, sun-synchronized, and pole orbit. So in geostationary orbit, that always match Earth rate of rotation of Earth to the satellite's orbit. In sun-synchronized, it tries to keep the angle of sunlight on the surface very consistently. And in polar orbit, it passes above both poles of the Earth. So it is usually satellite height above the Earth's surface, which determine the time take to complete the orbit. If the satellite is higher altitude, the orbit period will be increased. And according to the altitude, we can categorize orbits like low Earth orbit, medium Earth orbit, or high Earth orbit. Actually, the most of the weather communication satellites are in high Earth orbit, while the ISS and other satellites often in low. So the thousands of satellites orbit the sky above your head. So you might use them every day in different ways. So maybe you use internet to watch this lecture, and you read some weather reports to organize outdoor function, and sometimes you use GPS to mobile across the town. So already there are more than 4,500 satellites currently orbited. So, and still some are launching at that time. So astronomers actually worried about that these satellites don't have a much ability to study the night sky. And some people are worrying about what will happen to the debris of these satellites because it's very huge collection of satellites. And when we talk about the satellite, there are different kinds of satellite, and they use different kind of theories to categorize the satellites. So for the explanation, I will just talk about according to these categories. So my first category is open satellites. So under the open satellites, we have Landsat, Sentinel, MODIS, and etc. So the Landsat is the longest running observatory program with over 15 years of continuing remote sensing observation in our plan. So to continue this long-standing legacy, NASA launched Landsat 9 in last year, September. And Sentinel, it is also like a clear upgrade to Landsat, but it's missing the thermal band. And you might wonder why I put Corona here. So the Corona is a satellite which is used in military based in 1960 to spy on the Soviet Union. But now most of the archaeologists and some groups use these declassified images for the analysis. The second one is the commercial satellites. So the world view actually is so sharp that you can almost see the license plates of the vehicles. In fact, actually it is among the world commercial satellites, it can be ranked top as a satellite which can deliver the highest resolution. And there are some satellites, Iconos, which is a marvel in that time. And the third one is weather satellite. So there are so many weather satellites like TRMS, NOAA, and something like that. So here I have which uses the hand of Katrina. This happened in 2005. So here you can see how it's moved around the ocean. So actually, the Hurricane Katrina is considered as a tropical cyclone, which is struck Gulf Coast as the third strongest hurricane which hit the US. So actually, the storm initially formed at a tropical depression at the Bahamas, southeast of the Bahamas. So what satellite did is it passes around the Earth and just capture the image. So who made this animation? And the scientists are the one who really needed to identify, or there's a depression on this area, the ocean. So the hurricane might be happen, and it will be goes along this way, and this region might be affected. Those kind of things. So for that, we need to understand the interaction behind Earth system science, how the hurricane is formed and how it's move away, how wind affects, the things like that. So there are geodesy satellites, especially these satellites capture the Earth gravity, Earth pull, and other data. And the oceanography observation satellites. So they capture the many details about the ocean, like sea surface temperature, chlorophyll concentration, salinity, and others. You can use them to model the scenarios happening very well. So, as the Earth observation or remote sensing, GNSS is another geospatial technology, which is commonly used. What are the regional and augmented GNSS systems? So actually, these regional and augmented systems we use most of the time to boost the accuracy and dependability of GPS. And first one, Wide Area Augmentation System, which is operated by United States, and the second one, European Geostationary Navigation OLA Service. And third one, the next one, GPS aided geo-augmented navigation, which we call Gagan. And in Australia, they have new system now. So this distance from Australia, India, South Peninsula. So these are the active GPS stations, and you can see that in Japan there are a lot of stations, and so the picture shown how the volcano location is located Summit caldera, and when summit loses magma, and there are a lot applications of GNS like that. So we talk about GIS, remote sensing, GNSS, and the fourth one is 3D scanning. Going to talk about detail. So there are some best example like LiDAR, which stand for light detection and ranging. So in basically it use light in the form of pulse razor or to measure ranges to the Earth. So these light pulses combined with other data recorded by an airborne system, and then it uses to model the three dimension. And then the radar, so this is we in radar detection is gathered by the concept of echo. So you might know that when you shout into a well, the sound waves to your shout reflects off the water and back up to you. So this is similar when the pulse reflects off precipitation and sends signal back to the and how much precipitation is existing likewise. So other than these two techniques, laser, so with which is non-contact devices, it captures millions of data points to measure object and model the objects, and it uses laser infrared technology when modeling the object. So the actually categorized is into four, but it is very rapidly increasing and it's growing in. So there are some newly advanced technologies are coming with the miniaturization of sensors and self-driving cars and smart and also the augmented realities, and some are coming still invented about the our place around the geospatial. It is the difference between the growth and development. So population might grow, but the development of population is something different than the growth. So instead of increasing the size or the scale, we should develop ourselves so more in a more efficient state or a greater potentials to do something great. And so as students, it's your duty to understand the difference between growth and development. So then you can serve your best to the anywhere you are working. And so we can be patient, and thank you for listening me. And also I want to wish first and second of October. Congratulations and thank you.
Yes, thank you, ma'am. So, dear
Okay.
participants, now the time has come to get clarified about the issues you have regarding geospatial technology.
Yeah, Charming, since so I will try my best to answer anything if the participants have, but I will put my email here in the chat. So anyone, if you have any doubt, you can mail me.
Yes, thank you, ma'am. So, before winding up the session, I would like to express my sincere thanks to today's genius personality, Miss Panchali Umeshika Fonseca, for allocating your valuable time. Actually, thank you very much, madam, for the productive session. It was really beyond price. And also, I'm very much grateful to all the participants since your presence here is a tremendous support which lead today's session to success. So, everyone, until we meet again, stay safe and goodbye.